Hey there, everyone at Economics learning this video, it's Vikash Mishra, and today we're diving into the cool world of remote sensing in agriculture with the awesome Drive. Kamlesh Golhani. Welcome, Drive. Golhani.
Hey, Vikash. It's great to be chatting with the students at Sage University. Let's make this as chill and informative as possible.
Totally. So, Drive. Golhani, for our undergrad pals here, let's break down remote sensing. What's it all about, and how does it play a role in our farms?
Absolutely. Think of remote sensing as farming's high-tech buddy. It's like using satellites or planes to take super cool pictures from up above. These pics help us understand what's happening with crops, soil, and stuff without actually stepping into the fields. In further terms, satellites act as sensors, so we may also call them space sensors. For example, ResearchSat-1 and ResearchSat-2. These satellites are part of the ResearchSat series and are designed for resource monitoring. They provide data for agricultural applications, including crop monitoring and management. Radar Imaging Satellite (RISAT) series is focused on all-weather, day and night Earth observation using synthetic aperture radar. This technology is particularly useful for agriculture applications, as it can penetrate clouds and provide information about soil moisture, crop health, and land use. The Cartosat series is primarily dedicated to cartographic applications, providing high-resolution imagery for rural planning includes agriculture. Apart from this, we have Ground Sensor. Ground Sensor also did not step into field, but their measuring distance is low compared to satellites. These sensors target plant at a distance of 50 to 100 centimeters above of the crop. Spectroradiometers analyze reflected light for vegetation composition. Spatmeters assess chlorophyll content non-destructively in agriculture. UV from satellite imagery gauges plant health by analyzing light differences. Green Seeker Tech optimizes fertilizer use based on real-time crop reflectance, enhancing efficiency in precision agriculture.
Nice analogy, Drive. Golhani. Now, why is this so cool for Indian agriculture?
Well, India has this awesome mix of climates and crops, right? Remote sensing becomes our superhero gadget. It helps farmers know the nitty-gritty details about their fields, like if the crops are happy or if they need some extra care. Crop monitoring provide crucial data for monitoring crop health, estimating yield, and assessing the impact of various factors such as pests, diseases, and weather conditions. Precision agriculture. The satellite data helps in implementing precision agriculture techniques, optimizing the use of resources like water, fertilizers, and pesticides. Weather and climate monitoring. Aero satellites contribute to monitoring weather patterns, which is vital for predicting and managing the impact of weather events on agriculture. Natural resource management. Aero satellite data supports the management of natural resources, including land use mapping, soil moisture estimation, and water resource management.
Crop doctor from space. I love that. As well as fascinating functions of Indian satellite. Can you share a real-life example of how this tech helps farmers?
Sure thing. Let's talk about crop health. Imagine we're using satellite pics to check how our crops are doing. If there's a red flag, like stress or disease signs, farmers get a heads up. They can then tweak things like watering or add some superhero fertilizer to save the day.
That's like having a superhero team up with tech and farmers. But, you know, every superhero has its challenges. What unique challenges or perks do we face in India with remote sensing?
Great point. India's like a big puzzle with different weather, soils, and crops. So, it's a challenge to make tech that fits all pieces. But, here's the perk: once we crack it, remote sensing becomes this powerful tool, helping farmers make spot-on decisions tailored to their unique piece of the puzzle. In Indian agriculture, using satellites to watch and understand farms has some challenges. One challenge is making the satellite pictures clearer and more often updated so we can see details better. Another challenge is combining the satellite information with details we know from being on the ground to make better decisions. Lastly, dealing with clouds and air stuff that can get in the way of the satellite pictures is still a problem we're working.
Wise words, Drive. Golhani. Thanks for unraveling the mysteries of hyperspectral remote sensing and the superhero capabilities it brings to agriculture. And to our pals at this YouTube channel Economics Learning, keep those questions coming. Please like, share, subscribe channel and stay tuned for more mind-blowing conversations.